So let's go ahead and get warmed up real quick. So like last week, we had our system of equations. We were talking about 3 equations and 3 unknowns. So let's go ahead and see what you remember. It's just substitution. It just takes longer. So you got to solve for something and plug in the other ones. What do you guys feel like solving for? X's, Y's, or Z's? Pick one. X. Thank you. Which equation do you want to solve for X? 1, 2. Which one? Bottom. I like that. I would do the same exact thing. So 3. Let's go solve for X. So equation 3, if you get X by itself, you'd have to move the 6y and the 3 to the other side. So the 6y on this side would be a negative 6y. And if you added 3 to get rid of this minus 3, adding 3 to both sides, 4 plus 3 would be 7. So from equation number 3, we have X is negative 6y plus 7. Whole reason we're solving for that is so we can substitute it into the other equations. So we're going to plug them in and carefully just take our time, clean things up, and see where it goes. Equation 1 was negative X. So negative and X is this whole thing. So I got to put this whole thing in parentheses, negative all of X, negative X, plus 2y, plus 3z equals 4. And similarly, when you take that and substitute it into equation 2, it was 4x. So that's 4 times negative 6y plus 7. And then minus 2z equals 2. So that's what we got so far. And again, always remember what you're doing. You know, the whole reason we did this is now it's easier. It might look ugly still, but we have 2 equations with 2 variables in them. That's conceptually better than what we started with. So this is great, but it's a mess. So let's take a brief moment and stop and clean things up. Okay, equation 1, I see y's and z's. So let's just go in alphabetical order. I see positive 6y here from this distribution, plus 2y would be 8y. Z's, there's no z's in this thing. It's just a 3z, so plus 3z. There are numbers that negative times 7 would make a negative 7 on the side. But what are you going to do with the negative 7 on the side? You're going to add 7 to both sides, right? Move it over. And 4 plus 7 would be 11. So there's equation 1, much more compact and pretty. Isn't that nice? Similarly, for equation 2, let's go and see what we got there. Y's, I'll go in the same order. I see negative 24y's here and no other y's anywhere else. So negative 24y. And z's, I see no z's in this dude. I see a minus 2z there. So there's a minus 2z. And as far as numbers go, I see a 4 times a 7, which is a 28. But you're going to move it to the other side, make it a negative 28. And 2 minus 28 is negative 26. So here's our equations all cleaned up. Think we did everything right? Did I make a mistake? I hope not, because I don't make mistakes either. If I do, I'll jack up all my work. Okay, so here's a brand new problem. It's all clean and pretty for you, and you kind of just rethink it from scratch. How do you want to solve this, guys? Substitution, elimination? What do you feel like? I think elimination too. Yeah. Because I see this 8. I think, well, I could just multiply by 3, right? Be 24. So why don't we multiply the top equation through by 3, and then we'll see what happens. So equation 1 times 3. 8 times 3 would be 24. So it's 24y's. 3z's times 3 would be 9z. And 11 was on the other side, and that times 3 is 33. Equation 2 we'll leave unchanged because it already had a 24 in front of it. That was a good deal. And now I just got to think, what should I do? Add or subtract these to get the y's to be eliminated? I'd want to add them, right? Positive plus a negative goes away. So adding these 2 equations, the y's would cancel. They're eliminated. That's the point. 9z plus negative 2z was just 7z's. And on the other side, we hope this works out to something with 7's. And 33 plus negative 26 is 7. So dividing through by 7, we finally, after all that painstaking work, figured out that z equals 1. And now that I know z is 1, we're going to go back up the chain, plug it in somewhere else, and figure out other stuff. It doesn't really matter. I'm going to arbitrarily pick this one. Looks pretty short, right? It's got a z and a y. I know what z is. So if I go to equation 1 again, that would be 8y plus 3z. Now z is 1. 3 times 1 is 3. So there's equation 1 after I went ahead and plugged in z is 1. Moving the 3 to the other side, we get 8y is 8. And dividing by 8, we get y is also 1. So z is 1 and y is 1. Isn't that nice? Only one thing left to find, the x. So we're going to go back up and plug it in somewhere. That original substitution is a great place. It says x equals some stuff. So let's see what x is when we plug in 1 and 1 for y and z. Negative 6 times 1 would be negative 6. It just says plus 7, which is 1. So there's x is also 1. So your answer is 1, 1, 1. And of course, since you got an answer, what's the fancy word you should write? Consistent and independent. Yes, exactly. And that's pretty much all there is to that. Okay. Takes some time. It's a little tedious, but as long as you're not messing up distributions and all that kind of jazz, then you should have no problem whatsoever. All right, let's do some learning goals and get to work on this very last section for the unit, solving absolute value equations and inequalities by graphing. Now, to get this written down, you will need to get your graphing calculators out. Oh, he's so on the ball. He knows everything.
Good
Morning.
How are you?
Oh, okay.
I've been on a vaguely
Oh,
icy road.
I know.
I can never tell if it's ice or water.
Yeah. It was annoying today. All right. So your reveal stuff regarding the last stuff, systems of equations with 3 unknowns and stuff like that, that is due today. So hopefully you got that taken care of over the weekend. If you don't, that's okay. It's still not due till the end of the day at 3 o'clock. There's the last one for the unit before we start going to paper review assignments and all this stuff. In fact, this might be the last online assignment you do, because next unit I plan on going to paper only. So enjoy it while it's there. 2.9. That'll be due a normal 2-day turnaround on Wednesday. And let's go and get started. Today, the last section we are talking about is section 2.9. Solving absolute value equations and inequalities by graphing. No matter what ugly thing you're ever given in life, you can usually solve it by graphing, as long as you know how to set it up. At the very beginning of this unit, they had a section where you solved linear equations by graphing, and the theme was you set equal to 0, you graph it, and you see where it crosses the axis. Do you remember that at all? It was brief. I said it wasn't that important. That's not. But we're going to do the exact same thing here. We're going to cop out. We are going to set whatever we're studying, no matter what it is, equal to 0. We're going to graph it, and we're going to see where it equals 0. And we're going to use that information to solve the problem. All right, so first things first. The only thing I think you really need to know is this key box down here. This is what we're going to do. If you have an equation or an inequality, we're studying both today. It doesn't really matter. It's the same theme. You want to compare it to 0. You want to get 0 on one side of your equation, 0 on one side of your inequality, 0, 0, 0. And we're going to graph it. We're going to see what kind of answers we get. With an absolute value equation, since this is the shape of an absolute value graph, there's all kinds of different solutions. Maybe you get 2 solutions. That means it crosses the axis in 2 places right here, 1 and 2. Maybe it just bounces off the axis and there's only 1 solution. Or it's possible it never crosses the axis and there's no solution. So we're just going to visually see what the answers are. It's going to be very straightforward, no big deal. All right, so let's practice the first one. Very, very easy. All right, example 1, write her down. Solve 5 plus the absolute value of 2x plus 6. And apparently that is equal to 5. All right, so number 1, we did learn how to do this by hand a long time ago. So we will review that when we start reviewing for the test. But if you want to do this by graphing, what do you got to compare it to? What's the only note for today? Compared to what number? 0. Okay, so we got to get 0 on one side. I don't care where. Probably the easiest thing to do is subtract this 5. Would you agree? Okay, so we subtract 5 from both sides. And get rid of this 5 too. So really, we're just looking when the absolute value of 2x plus 6 equals 0. So we go graph the absolute value of 2x plus 6 and see when it equals 0. A really easy lesson today. So you go to your y equals. And if you want to find anything, catalog is always the best spot. In fact, it's probably the easiest way to find absolute value because your catalog, second to catalog, 0 down there. The first thing in the catalog is absolute value, so you can't miss it. It's got ABS, and you hit it, and you type it in just like it looks, 2x plus 6. You don't write to equal 0 because we're trying to find out when this thing equals 0. So you set whatever the equation is on the other side into your y equals. Never hurts to do a zoom and a number 6 to reset your window. Never hurts. And then you go look at it. And this one, we're looking for where it's 0. That just means where it crosses the x-axis right here. So it looks like it's right there, correct? We want to guess. So it's always good to do a second calc. And they have that 0 function right there, number 2, 0. I hope this works on this. So you go somewhere to the left of it. I'm not sure this one's actually going to work since it bounces like this, but we're going to see. Somewhere to the left, somewhere to the right. I wonder if this is even going to work. Oh, there it is. I found it. And the key thing you're after is not the y, because you're looking for one at 0, and it obviously says y equals 0. You're looking for the x. You're looking at what's in the equation, the x. So the answer is x equals -3. You write it down, and you're done. That's pretty much all there is to it. No big deal. X equals -3. Easy peasy today. And you can go through a bunch of tables and nonsense if you really want to, but that's not the point. We're just trying to figure out when something equals 0, and that's it. So let's try this one out. Here we go. Solve absolute value of x plus 1 plus 9 equals 13. One quick step, and we can have this thing compared to 0. What do you think we need to do to get 0 on one side? Subtract 13. I'm down with that. Yep. So let's go ahead and subtract 13 from both sides. You had a 9. 9 minus 13 on the left would be -4. And now it equals 0. So same deal. Back to the calculator. Clear it out. Second catalog. Absolute value. X plus 1 inside the absolute value. Make sure you go out of the absolute value. Hit the right key to get out of it. There's more stuff. And then -4. And it's ready to go. So zoom 6. Here it comes. Oh, now this one seems to cross the axis in 2 spots. So there'll be 2 solutions for this one. We got to find out what they are. So same deal. Second calc. Zeros. And it doesn't really matter which one you do first, but I'm going to go in a logical left to right order. So going somewhere to the left of the one on the left. Boop. Somewhere to the right of the one on the left. Boop. And hit enter and you get -5. So write it down. X equals -5. That's an answer. Similarly, to find the other one, second calc 0. Somewhere to the left of the other one. I like to get kind of close. I don't want to be way off. It doesn't have to be exact science, but somewhere like that, sure. And then somewhere to the right of it. Whoop, whoop, whoop. There we go. And you hit enter again, and you get x3. So there's your 2 answers. X is -5, I believe it was, and x is 3. Very straightforward, isn't it? Nothing hard about this. I like that. So there's that one on there. All right, now they can get more complicated, but the theme would be the same. Let's just try to do this one without going to the board. So what would you have to do? Just subtract the 11, correct? And I'd have, what's 8 minus 11 on this side? -3, right. So let's go graph 4/5 of this stuff. So go back to y equals 4/5. How do you type 4/5 in your calculator? You just do 4 divided by 5. Yeah, that's a fraction. 4/5 times the absolute value of, and if you go back to the problem, it was x minus 1 inside of the absolute value. So x minus 1 inside. Get out of there. Use that right arrow key. Get out of the absolute value. And you just said it was -3, right? After we subtracted the 11. So we'll hit -3. And we're good. And there it goes. Again, there's 2 solutions. A lot of times there might be 2 solutions. And you do your second calc. 0. I'll find the one on the right. It's the same process over and over again. Let's just get one of them. Whoop. One on the right is ew. Oh, that's not right. That's better. 4.75. So we'll write down 4.75. I prefer fractions, though. Does anybody know how to convert 4.75 to a fraction? You can always go back to your home screen, though. 4.75. If you ever need to convert something to a fraction, this math button here on the top left, the very first thing it says is 2 fractions. So if you just hit enter, I prefer this answer. 19/4 is an even better answer. Decimals are okay once in a while, but for the most part, we want to avoid them and do fractions like that. And if I go back and I want to find the other one, I do the exact same logic. Second calc, 0. Somewhere to the left of it. Somewhere to the right. And this one is negative 2.75. And again, probably should go back to your home screen, type in negative 2.75. And math to fraction number 1. So the best answer there is negative 11/4. So negative 11/4 and 19/4 would be my solution for that particular problem. And it's the same thing over and over again. So let's not do this one, but how would you set this one up? Well, just the only thing you'd have to do for this one. Add 10. Yep, add the 10 over. It's equal to 0. Graph that stuff. See where it crosses the axis, right? Now, let's talk about solving absolute value inequalities. Down here, I have really this exact same note. Compare, I can't say set equal to because it's not an equal, it's not an equation anymore. But I can still say compare it to 0. Now, with inequalities, that's when something's more than or less than, so this will involve shading. I'll shade above the graph, or above the x-axis, or below the x-axis sometimes. Beyond that, it's really the same kind of deal. We just have to think about where it's less than 0. If something's less than 0, that means it's below the x-axis, correct? And something's more than 0, that means where it's above. That's all there really is to this stuff. So let's see what kind of answers we are going to get. What kind of shading? I mean shading on a one-dimensional line, not like on a plane, but we'll see. It's really, really easy. Okay, here we go. Let's write this one down. Solve the absolute value of 3x minus 9 minus 6 is less than or equal to 0. So this one, are we looking for where it's above the x-axis or below? If it's less than 0. If it's less than or equal to 0, you're looking for below, right? Less than, lower. So it's already set up and ready for you to go. We're going to do the exact same kind of thing. You go back to your calculator, go back to y equals, and you type in just like it looks. First thing was the absolute value. Inside of it was a 3x minus 9. Get outside that absolute value. We also had a minus 6 on the end, so minus 6. And let's go graph it now. So hit the graph button or zoom 6 if your window's kind of messed up. All right. So if you want to find where this thing's less than 0, it's probably a good idea to start by figuring out where it is 0. So just like before, I want you to do the same thing. I want you to do second calc. 0. Somewhere to the left of it. Yes, sir. Yes, you may. Somewhere to the right of it. And the first one's at 1. Make a note to yourself. The first one was at 1. X is 1. That's a number. I'm not saying that's the answer, but that's a number where it crosses the axis. We'll do the same thing for the other one. Second calc, 0. Somewhere to the left of the other one. Somewhere to the right, and hit enter, and you get 5. So there's our 2 zeros. Now, why do I want these zeros? I thought I was looking for, well, first of all, if you look at the equation, what was the equation saying? It was less than or equal to 0, correct? That's where it equals 0. Less than 0 would be where it's below the axis. Do we agree with that? Where it's below the axis. So where's it below? Where's the graph below the x-axis? Anywhere between 1 and 5. Would you agree with that? Anywhere in there. So how am I going to write my final answer for this? Well, if it's any number from 1 to 5, should I include 1? Yes, I should, because it's less than or equal to 0, correct? And should I include 5? Yes, for the same exact logic. So anything from 1 to 5, including them, meaning your answer to this is bracket 1, and then all the numbers from 1 until 5. So you get a range of numbers out that works. You don't have to, you can shade this on a number line if you wanted to. I'm not even going to make a shade. Don't worry about that. But you see how we got the range of numbers. that make sense? Okay, so that's kind of all there is to this today. Let's try another one. All right, how about this one? Absolute value of x minus 2 minus 3 is less than or equal to 0. So you go to your y equals, clear out what you got, type it in. It's already compared to 0, right? That's the only step you have to remember. So second catalog, absolute value. Inside the absolute value is x minus 2. Outside of it is a minus 3. Zoom 6 or graph or whatever. And there's that shape again. And same exact kind of thing. We're going to figure out where it equals 0. Even if it was less than, even if you didn't care if it was less than or equal to 0, you'd still start the exact same way every time. Second calc, 0. I'm going to find the one on the right. You guys find the one on the left. We're going to tag team this thing. Tag team back again. Check gets erected. Let's begin. I got 5 over here. That looks like -1 over there. Did anybody confirm that's -1? Okay, so -1. So again, this thing is saying you're looking for less than 0 below the axis. And it can equal 0 too, right? Less than or equal to. So same exact kind of answer. It's just going to be -1 to 5 on this one. So answer to this one, -1 to 5. Nice and easy. And it'd be the exact same logic. I mean, you can see this is kind of straightforward today. For anything else, if it was greater than or equal to, what would you look for then? Where it's above the axis. So just for good measure, what if this equation had been greater than or equal to 0, and you looked at this thing? Well, where's it above the axis? Anywhere to the left, correct? And always go left to right, right? So you'd say from -infinity until -1, right? And then you'd skip over this middle junk because I don't want the less than. And then you'd say from 5 to infinity. Get the gist? It's pretty straightforward today. I think it's a nice little thing to go out on the unit, I think, because it's very straightforward. So that's it. That's 2.9. Just compare it to 0. If it's an inequality, look for the range of numbers that make it true. And if it's an equation, just look for where it exactly crosses the axis. No big deal. All right, I'll let you guys work on 2.8, finishing that up today. 2.9 for Wednesday. You will have time tomorrow in class to work on it, and today too. So should be very easy to get these taken care of with a work day and today. So, all right, have a good day, everybody. Yes, you may.